So, Pavana and I are working in the same team. We've been working with the client since, well, I've been working with the client since I joined Thoughtworks quite a while ago. I'm the joint tech lead of the platform team there. We are building a platform in public cloud for the client. We are targeting the replacement of a legacy platform which is run on premise. I spent over 20 years working with infrastructure. I've worked in the public sector, the private sector. I've been an employee, a consultant. Most of my time in the team is spent writing Terraform and automating the pipelines. I've also given talks about infrastructure in pipelines and why it's so important, but that's a different talk. Pavana, who is one of our senior infrastructure consultants in the team, she takes the lead on the networking parts of in the team. She's worked in multiple cloud migrations in both Germany and in India, including healthcare, telecoms, and HPC migrations from different platforms and the sort of challenges that come from that. What we're going to talk about is that because we are external consultants to our client, we have to actually prove to our client that they can trust us. Their security people, the networking people, all of those parts of a sort of large, complex organization like our client, we have to convince them that we are actually sort of people they want to work with. We are able, and all things that when you're migrating applications from one place to another, you have to trust the people who are doing that. We'll also talk about how we've applied Agile working practices to networking and infrastructure, and how those have allowed our team to deliver quickly and effectively. And finally, we will cover in some detail the technical implementation that we've built, which is based around AWS's private link technology, and how that has allowed us to scale our team, make our platform successful, while keeping the client's security and compliance parts of their sort of teams happy. And now, what was the problem we were facing? During projects which sort of move from one environment to another, both Pav and I have sort of had the experience of what networking actually is in place. Do teams understand how their networks, what their sort of applications do? How are they talking to different parts of infrastructure? How the firewalls are requested, how they're set up, and even just sort of asking the question, so what does your application talk to? It's often very complicated. It's often hard to understand from the delivery team who've been in place for multiple years. Actually, what do they call? Is there somewhere deep inside their application, do they call out to some legacy backend system that we've never heard of? And the thing that we've often come across is that when we start moving an application, we want to make changes, and teams are asking, oh, I need access to this system I forgot to tell you about. We need to be able to do that quickly. And we've often experienced that is not well understood, and getting to that understanding is very hard. The other thing is that once we find that understanding, we end up with a complex process. It ends up with you have to fill a firewall change request in, you have to open tickets via email. Sometimes, certainly the client we're dealing with at the moment, complex technical firewall requests are raised by business stakeholders, not technical stakeholders, because they are considered to be a business system, not a technical system. So we've often had to sort of support people who may not have a particularly deep understanding of networking through actually, you need to request this, you need to open this traffic flow, you need to talk to these people about the systems that they have built and how we do this. And the client that we're dealing with at the moment, sometimes changes like this are implemented once a week. So you make your change request on a Thursday, that will actually be applied on the change set of the following Wednesday. So you have over a week to wait, so nearly a week to wait before you actually know if your change is correct and if it's actually worked, which is very hard to sort of work with when you're migrating an application from on-premise to public cloud, doing that at speed. These sort of things take too much time. And now Pavana will talk about how we actually did this.
Thank you, Tim. So how did we engage and build trust, right? One of the things that we noticed, at least in our case, was that it is really, really important for the engineering teams that are already there and for the team that is now trying to build the platform to trust each other and care for the systems, right? To show that we care for the systems as it was done earlier. Now, two problems that Tim mentioned, right? One was identifying the network flows that are already there in the on-premise world, and then extrapolating it and bringing, making use of this for connecting it to the cloud while we build the new platform. And then the next problem was that how do we use this with the process that is existing mainly for raising the requests that we want. Another thing was we are external consultants and there are existing teams there, right? And these existing teams have spent decades sometimes caring for these systems. Now, what our team mainly had to do was to demonstrate that we have expertise in networking, we have expertise in security, and only then we would show that we would get trust established between these two teams. So this was one thing that we learned along the way, right? Next slide, Tim. Thank you. Now, while we started learning about the network, various network flows that were involved, it became very important for us to understand the current design that was, that is already there. And along with the current design, we started to understand that we need to respect the history of all the processes that were there, the way the systems were designed, the way the networking flows were there, right? And we also had to learn about the processes that were already in place. Now, large organizations usually have decades or more of experience, and that really needs to be respected. And we can actually, we learned that we can have change without throwing away all those years of experience. With all the new technologies that we have, we learned that we could still have, we could move really quickly along without throwing all those years of experience that was built into these teams. So that was another thing that that we learned along the way. So there's a lot of history, and that history has a lot of knowledge in it. And when we this prevented us from not doing those mistakes again, right? So that was one thing that we also learned along the way. Next slide, Tim. Thank you. So this is a slide to show what is, these are some of the agile practices that we usually follow in Thoughtworks. So this slide is this is a picture that we had. And yeah, and apart from that, these agile practices actually helped us to move quickly. So what did we actually do, right? What did we actually do to get to learn all these network flows? What we did was we understood that it was important for people with some networking knowledge, some networking expertise to go for these initial discussions. What I've noticed previously was sometimes business, it could be POs who go for some of the discussions. And in our case, what happened was, since these were people with the networking expertise, it was the same language that they ended up speaking. So you had people from the on-premise world, from the networking teams who would come, and then we had people with some networking expertise from the platform that we were building who would go and talk, who would talk. So it was the same language that was being spoken, and that really helped in the initial discussions. So that's important. You need to have some expertise within the team that you're, within the platform that you're trying to build. eventually you will also have to spread that knowledge within your team. So not just one person. So initially it might happen that you might have just one person or two people with some networking expertise, but try and get that knowledge shared around the team. So that helps them to, build and make the team more stronger. That's something we actually did, right? And that helped. The third thing that we noticed was, what did this actually help us, right? Where did this help us? This helped us by actually we got these network. There were quite a few of them, and we got it all mostly cleared within like less than 2 months. And these were complex discussions, but since there was some network expertise and all talking the same language, it took lesser time. Now, apart from that, we used a lot of agile practices while talking about networking discussions. So what do I mean by agile practices? So we had discussions mostly using a board or using stickies, where we prepared before the meetings extensively. So those stickies that you saw the picture of previously, so we would prepare extensively using this and then go for those meetings. And while the meetings were happening, we had boards there, so that most of the times it was drawings to understand. So one thing I've learned is that, especially in networking discussions, accents, language could be a problem. And when you have a drawing board there, it really helps. So that's another thing that we wanted to share. Apart from that, I think, what else? Yeah, we had also an MVP, like sort of a first mover for a platform, who would, using whose network flows we would have most of the discussion. So some sort of an MVP we had during the discussion. So that also helps. And I know this is the COVID world, but meeting in persons at that time really helped. I think today, definitely, I mean, meetings do help, but those in-person meetings were very, very helpful. So I had to add it. Next slide, Tim. So, right. So coming to meetings. So networking, on-premise networking teams, right? There would be, in our case, it was a really large organization. You would have different teams for different different networking aspects, right? Maybe VPNs, maybe IPs, and then you could have it for the security, firewalls, and numerous other teams that are networking teams that are there. And early in the project, we learned that a really big meeting is very difficult, because your meeting could go on for really long. One. Second, it could end up being such that you don't get a lot of things achieved during that, right? So what we started doing eventually was, we started having really small meetings, and then and these meetings became very, very tight agenda. So what do I mean by really small meetings? We started identifying what is the network flow we wanted to discuss? Who are the main decision makers in this, to get such a thing cleared? And we had this really small meeting, and we would have it in person, and that really got us, got us going quickly. So that is another thing that I noticed and I learned during while doing this, right? And it's really important for you to have the right audience for these meetings. If there are quite a few people, then it becomes difficult for you to achieve something out of this meeting. And to even have like an interactive discussion, right? Like when you're on the board, if there are about 3 or 4 people, it's really easy to draw and talk and understand all of the flows easily. And it's also important to know who's the key decision maker when it comes to most of the network flows or the security firewalls, right? because that person will later help you, will already know what is that you have discussed, and this won't go into loops of firewall requests. At least that's something that I have learned. Right. Uh, can we go to the second? Yeah, thank you. Right. Now, what are we talking about scaling bureaucracies? So while it comes to large organizations, right, there is some level of bureaucracy built into them, right? And a significant overhead of moving to a hybrid cloud environment is managing the existing network security processes. And what I mean by that is firewall requests. Now, coordinating this firewall request requires both some level of technical network expertise, but also the knowledge of the organization and its history and its existing processes. And since ours is a platform that we are building on the cloud, we would have numerous teams that would get onboarded onto it. That means we would have to repeat this work numerous times for all the teams that get migrated, right? So that is another thing about how the organizations work in terms of security processes. Now, one thing that I noticed was that when it comes to existing network security processes or the firewall requests, it generally doesn't just go to one team, or you might not even know who is the team. It could be several teams at the back that are there, right? So this is something that I have learned. So this is a really complex process when it comes to firewall requests. Another thing is what we've learned is, as Tim mentioned, right, some of these change requests get done once a week. At times it is, when it's done wrong, then it takes quite some time to rectify it. So all the challenges that we have noticed with firewall requests. So how did we overcome some of these challenges? So Tim, if you could go to the next slide. Thank you. So we collaborated with one of the networking experts from the on-premise world, just one person who knew all of the who knew all the processes that were built into the client's on-premise networking world. And then what we did was we built our team's expertise in networking, and then we collaborated with this expert from the client side. Now, what this started, how did this help us actually? Now, in our case, it would have been multiple requests because there are multiple teams that onboard onto our platform, right? So we would be making multiple requests for multiple teams migrating to the platform. Now, since it was just one person from the on-premise, a networking expert, basically, I'm talking about, and our team that is involved, this saves a lot of time and confusion and communication overhead that is there. Otherwise, there would have been several POs who would be reaching out, or several tech leads who would reach out, or sometimes several engineers from these teams who would reach out to get all this, and that knowledge share would have been difficult. So in our case, we did that, and that really helped us in terms of time and communication overhead. This also gave us quicker feedback loops, and it ensured the accuracy of the requests that were going in. So it was kind of building up the knowledge. So both the networking expert knew what was happening. Our team already knew what was the kind of network flows that we had already discussed. So when customer teams that were onboarding onto our platform came in and asked for something, we already knew kind of, okay, this is the network flow that we're discussing here, and we could put the right request there. And so most of the, I guess it was 95% times it was accurate. And if there was even a time where it was not accurate, it was really easy for us to get it rectified, because we knew, because we were partnering with this network expert who knew all the teams inside, who knew all the terminologies that the client was using. So it was really smooth even to get things fixed. So that was our learning from there. And can I have the next one? Thank you. And I'm here talking about Grow Your Supporters. This is now, what do I mean by Grow Your Supporters? One of the things that we saw along the way was that as we collaborated with some of the networking experts from the on-premise world, they started enjoying working with our team. Another thing was they were collaborating with us most of the time, so they started investing in our project. So that really helped. They saw the benefits of what we're doing. They saw upfront what is our plans, what we intend to do, what is our architecture, what is our design, uh, everything we shared with them upfront, and that really helped. And we also showcased our code. We shared our experiences with them. We also had them in our communication channels, and they were a part. They became a part of our team. If, though not directly working, but indirectly knowing what was going on. So it wasn't like a one-time meeting or a 1 month of meeting continuously and then someone disappearing. That was not the case. In our case, it was. So they are constantly involved and they are invested in the project, in the project, and that really helped us. And by doing all of this, I see that the culture bit really has a big impact. So how well your project does, how well your initial onboarding to the cloud actually goes. It could have been not so smooth if we hadn't done some of this trust building and partnership building in the beginning, that we really that we really appreciate now. So that was what I wanted to share, and that was all the learnings that we had in our team. Tim, do you want to discuss on the technical bits on how we did this?
Thank you, Pavana. So that's sort of discussing what we did in sort of building trust across the organization and convincing people we were good people to work with. And now the sort of hard technical work of actually how we integrated these systems, these teams into sort of public cloud and on-premise systems. First of all, I've put a little bit of a primer in for something that is I will refer to quite a few times, which is software-defined networking. It's really network virtualization, and it's in the same way that virtualization like VMware, like Hyper-V, like KVM, disconnects your virtual machine from the hardware it runs on. Software-defined networking disconnects your networking objects like network load balancers, like connections between different parts of your infrastructure. It's disconnected and invisible from which hardware device it's running on. This is quite important when we get to the next stages of how we worked with AWS and how we made use of virtual networking and software-defined networking. This is built into all the sort of major cloud providers. It's built into VMware. There's an open source implementation called Open vSwitch if you want to play with this more on your sort of local systems. But now we'll talk about using this in public cloud. I'll talk about three main pieces of infrastructure that we use in AWS. A network load balancer. This is a standard layer 4 TCP load balancer. It connects to backends in our client's on-premise world. It gives our teams a single entry point. AWS Private Link is a SDN sort of fabric connection that connects a VPC endpoint to a different VPC. So it lets you do a connection between one AWS VPC and another without having to do VPC peering or without having to use transit gateways. This is, the way I think of it at least, is that it's effectively a long, invisible network cable between two different parts of AWS's cloud. And the last part I'll talk about is the VPC endpoint. this is a AWS construct that lets us publish a network load balancer in this case from one VPC to another and manage the security around that. And now this is how we started from the technical implementation of accessing, in the example here, a database system on premise. So the first thing we did was we built a network load balancer that targeted the on-premise system. So this is a normal network load balancer. The target groups are set to point to the on-premise system over here, and we connected a VPC endpoint service to it. This meant that we got static IP addresses. We could allocate static IP addresses to our load balancers here. We could fit that into our client's existing firewall and governance models. The only little bit of complication that we had to deal with was that this VPC endpoint service gives us a random identifier, which we have to pass around between different pieces of our code. The other nice thing you get with a network load balancer is that you get active monitoring from here across the VPN to the on-premise system. So we can actually see failures in VPN or failures in the client's on-premise systems. Now this is the magic part with AWS Private Link, or as our team's networking expert from the client described it, the Magic Wormhole, which I think is quite a good name for it. This is a connection within the AWS software-defined networking fabric that connects from one VPC over here on the right down to another VPC over here on the left. There's no VPC peering here. There's no direct networking. There's no transit gateway. There's no routing. The team here, this infrastructure here, has no way to send any traffic across the VPN apart from what goes through the load balancer, which means that the security teams in the client never lose visibility of the rules that are in place. We can be very, very strict indeed about what rules are applied to this traffic. We can be really clear about who can see the flows. We have VPC flow logging for all of this, so we can actually show every single piece of traffic. We can't show the content, but we can show the actual traffic path. And this is connected to the Teams account as a elastic network interface. It's effectively a sort of end of the cable, the other end of the cable here for private link. We can attach security groups on the front of this as well here. If we need to do further security group protections for particular parts to split traffic in the team account, so only some parts of the team account can access this service. And the next piece we have to do is override the DNS name. In order to get the TLS certificates to match from over here to over here, we have to intercept the DNS and pretend here that we are, that the on-premise system lives here. That is very straightforward with Route 53 private zones. And it is, as far as this team is concerned, they are talking directly to this on-premise system here. The cabling that we have built with this is completely transparent. It's a completely transparent, high availability, high bandwidth connection that as far as the delivery team here is concerned, they access the same DNS names, the same protocols, the same ports, and it just goes through AWS public cloud to our corporate data center with a database running in it. What the platform team don't do is actually provide anything like authentication or authorization. We just provide the cabling. The team here is still responsible for getting access to the database here. They still need to request usernames and passwords and client certificates and all those pieces. You need to do authorization and authentication. We just make a guarantee about traffic delivery. Effectively, there are no changes required to normal security practices. This team requests access from this team, and we just do the wiring. We, the platform team, do the wiring in the middle. Now, at the moment, this is the same as normal. This is just a complicated extended wire that goes in public cloud from a team to a database. But a second team could also join this. So this second team doesn't need to do any firewall clearances. We don't need to request additional firewall rules because we're coming from the same 3 IP addresses here. three IP addresses for 3 availability zones. So this is a static set of IP addresses. But this team here and this team here can both go through the same load balancer to the same backend system. So the traffic flow here is already agreed. This team here doesn't need to do any complexity of asking for access for firewall clearances. They still need to get authorization and authentication. But now, rather than having to do a week's worth of firewall work, we can push a Git commit to allow the access rules, and the infrastructure is deployed and working. So this team can gain access to an on-premise system at the same speed as you gain access to a public cloud object. It's just the same speed because we're building public cloud objects and wiring them together. We're not going through existing processes. We are building on top of those processes in the cloud native world. Now, the second team needs a new service, so access to the message queue on-premise. They still have to go through the same process because they're the first people to have requested that. So the team here makes those first requests, and we make them, actually the platform team makes the requests for them to make sure that they're done correctly. We build out the infrastructure and allow them to wire into it, but the sort of process is already well defined. We expand this sort of code here in Terraform very straightforwardly. We also have a full audit record of all these changes, so we can tell who put all these pieces in place. We can make sure that the only people who are making changes to this are authorized people. What we would really like to do over time is actually give this whole transit services account that we currently, the platform team, own to the client to manage. So we think that the client security teams could take responsibility for this. It's a well-defined application, it's a well-defined account, that the teams, the security teams, as they grow into public cloud, could take ownership of this. And we keep building code on that basis that this team account, we could slice it out of our work and allow a new team to take it over. So far, we've talked about outbound traffic from our delivery team customers over here, from our platform customers here and here, talking to on-premise systems over here. We've built a relatively scalable, effective, highly reliable set of cabling, which allows those teams to connect to on-premise systems. But these teams write services. They want to be able to have access to those services. So the next part we need to solve is how does a user in our client access these systems? So we start with the delivery team here. They define an NLB, same infrastructure, same technologies, but in reverse. So they define an NLB which talks to the Kubernetes ingress. So this is so we give our teams a pre-configured Amazon EKS cluster. And the team's ingress target is running in the Kubernetes cluster with a network load balancer attached. That's all built into AWS. We attach an endpoint service to it, which allows us to do the cross account publishing that we need to do. So once again, the same way as we were doing it before, we wire the VPC endpoint together using private link, but this time we're terminating in our account. So we're terminating our client's IP addresses that are used within the client's organization. We're terminating those IP addresses in our public subnet, and we're connecting that together back to this delivery team here. There's no direct networking path. This is only a publishing of load balancer. Only published services that the team has flow over this. So there's no direct access from this account to this team's account. There's no networking flow. We can also put security groups here. If there's requirements for firewall requests to be put in place, we can do the security groups here. So we have full firewall management processes as well that we can apply here. So if we need to integrate with the client's existing firewall systems. Now we have the final part of the connectivity back to our team. We have a DNS record that we publish in our transit services account, which makes reference to this team's services. And we publish that DNS record. It's used by the corporate officers to find the teams. We have Free-cleared the IP addresses in this range here for access within the client. So we can, again, take workload off our delivery teams. We can have agreement that these IP addresses here are already allowed to be accessed from the corporate offices. In the future, we will probably have teams interconnect with this. At the moment, teams are only currently concerned about connections to and from the corporate data center. In the future, we'll probably connect teams together using this technology. Again, we push that trust relationship down to the teams. So if the team A here trusts team B, they can connect into these VPCs. They can trust each other to run services. It's completely decoupled from the platform team. We are not a bottleneck in the process of getting teams access to each other. So this is the sort of the full example of how we have our purple inbound traffic from our customers' users in the head offices. We have our teams able to access legacy on-premise systems through a scalable, managed on-premise public cloud system. We can retain all of those security practices that our client requires. Only teams who need access to systems can access them, which we can enforce with auditable change records through Git and through CloudWatch. So we can actually say particular pieces of infrastructure are only deployed to this team, and we can prove it. That's a really powerful tool. It means we don't have to do record keeping so much as we know that the Git code reflects the AWS code, and every change is logged. We don't have to concern ourselves with all that the sort of historic record keeping. We can say this is what reality is. The platform team doesn't have to worry about TLS certificates or traffic or security controls on the traffic flow, because all that we're guaranteeing is that the traffic flows. We don't have to do anything around security, TLS certificates or anything like that. We just concern ourselves with, is the traffic in place? Is an authorized traffic flow going through? The teams do the authentication pieces and the authorization pieces. It builds on top of our clients' current processes and our clients' current thinking. So to wrap up, this is how our platform team is successful. We've gone from so we were looking back a few days ago, the first commits that we made to Git, the first Terraform commits that we made were the 4th of December last year. We delivered working accounts to our customer teams on the 30th of June this year. So we've gone through the process of building trust. We've gone through the process of building the infrastructure. We've defined our processes. We've found our customers. And now we have 7 customer teams on our platform, and we are growing within the client. We built trust by respecting the client. We demonstrated our expertise. We proved that we were actually people who knew what we were talking about by leaning into the client's processes, by looking at why are you doing this process? What is the challenge you're solving? How do we reassure you that you're still in control of the pieces of your infrastructure that you care about? There was also the really simple thing that we're actually quite nice people. The office that we worked in when we used to work on premise, we went and stole a sofa from one of the client's shared spaces. We always made sure the room was well supplied with snacks. People came to our room to chat. They came to our room to spend time with us because we were nice people with interesting ideas who could solve problems. We applied our Thoughtworks agile thinking. We found the vision. We understood what the client wanted to achieve. The product owner of our team, he wanted to replace a legacy platform. He was really clear about that. We knew what that vision was. We could identify that vision. We could identify what work we had to do. We could slice that work into small pieces. We could make sure that that work was delivered so our first customer, who we found and worked with, could actually move into our platform quickly. They were a customer who we could sort of say, does this customer care about this particular problem at the moment? No. We can defer that problem. We can solve that problem later. We could identify individual pieces of the work which didn't matter to the customer straight away. We could then solve that problem in the future in different ways. We built momentum. And finally, we took a technical solution which was making very creative use of some AWS technologies. And we made sure that this is all a managed solution. We don't use any of the some of the tools that add complexity, like HA proxy, networking devices. We looked at things like running cloud-hosted network devices, and it would mean that our team then ends up as a permanent network administration team rather than being a platform team who write Terraform and run pipelines. We would become network administrators writing firewall rules. That's not what we wanted to do. We removed blockers from our teams. So by pre-clearing traffic flows, by pre-building solutions for our teams, we got out of the way and let our teams innovate in public cloud. We understood where the governance mattered for our client, how we could retain and improve that in public cloud, how we could maintain that audit trail, how we could maintain that record. We believe, excellent records of every single piece of traffic flow, every single change. We have records that go back to the very start of our platform. We can show everything that's taken place. So if we ever do have an issue, we can walk that trail and understand it. And finally, back to the thing I was talking about right at the start, we deploy quickly. We deploy, as Eric mentioned, we don't deploy thousands of times a week, but we're probably at hundreds of times a week for deploying Terraform code from one team. We deploy all of our Terraform code, we push to master, we run our tests, we deploy our infrastructure. We maybe push 200 change sets a week through our infrastructure pipelines from 20 people. We move quickly as a team. And that's because we have people like Pavana and the team around us to collaborate, to share practices, to build, and to work with our client. And also to be nice people. So, thank you very much for listening.